Dear learners, happy learning.
Today we are going to learn about number system part 2 session under fundamentals of computer and working with typical operating system. Okay, this is your chapter 2 under that part 2 session. So before going to part 2, we just make a small recall of your part 1 session under number system. What are the things so far learned? We saw about what is data and how to represent your number system. So it is one of your machine language, that is zeros and ones should be represented as binary digits. If the digit is 4-bit, then it is called as nibble. If it is 8 bits, means it is called as byte. Similarly, word length refers to the number of bits processed by a computer CPU. So in computer memory, you will have two main types. One is main memory, another one is secondary memory. Then we saw various size. Based upon the size, how you can differentiate your data representation based on kilo, megabyte, gigabyte, terabyte, petabyte, exa, zeta and yottabytes. Okay, then we saw about what is ASCII, American Standard Code for Information Interchange. Then we saw different types of number system. Under that, mainly we will have 4 number system. What are those, ma? Decimal, binary, octal and hexadecimal. Then we saw about the base values of that. So what is the base value of decimal? It is 10. Base value of binary is 2. Base value of octal is 3. Similarly, base value of hexadecimal is 16. So those are all the things we saw. Then under number system conversion, what is LSB and MSB bar? LSB represent least significant bit and MSB represent your most significant bit value. Next we saw about how to represent binary, octal, hexadecimal equivalent of your number system, right? Okay, let us see today's objectives, learning objectives. First we are going to learn about, in previous session itself we saw how to convert decimal to binary, similarly decimal to octal, decimal to hexadecimal. 3 conversion we saw. In today's class is going to learn about conversion of fractional decimal to binary, then binary to decimal, binary to octal and binary to hexadecimal. These 3 categories under binary conversion. Next one, conversion of fractional binary to decimal equivalent. Okay, next octal to decimal conversion, octal to binary conversion. Okay, then hexadecimal to decimal, last one hexadecimal to binary. So these are all the learning objectives of today's session. First we will see about how to convert the fractional decimal into binary. Okay. So take down the procedure, method of repeated multiplication by 2. So this is the method in which you are going to convert your fractional decimal to your binary part. Okay. So first step is multiply the decimal fraction by 2 and note the integral part of it. Integral is either zeros or 1. Okay, discard the integral part of the previous product. Multiply the fractional part of the previous product by 2. Repeat until your step 1 for a same fractional repeats. So until you have to continue your looping state. Clear, ma? Okay. Next step 3. The result of your integer part, no, it should falls under the sequence of zeros and ones, means that become binary equivalent of your decimal part. Finally, write the return from the first integer part obtained till the last integer part obtained until you have to write the value of that. So these are all the steps for converting fractional decimal to binary. Now see in this example, here point 2. Okay, you have to point 2 to the base 10. You are going to convert this one to your binary equivalent. So this is your decimal value. You are going to take and convert for this part. Okay, let us see how to convert that one. So first thing, you have to take this 0.2. So I am taking 0.2. What is your first step, ma? You have to multiply by 2, no? So that is your step, no? Multiply the decimal fraction by 2. Okay, I am multiplying 0.2 into 2. So the value is 0.4. So the integral part is 0. That one you have to write this one right side. Next 0.4, that one you have to take it as input. Then into 2, 0.8, you have to write 0 here. Integral part 0.8 into 2, 1.6. So integral value is 1. 0.1 will be gone here, so it will become 0. 0.6 into 2, 1.2, 1 will go here, so 0.2. So 0.2 into 2 is 0.4. This is the value that should be exist already, no? So this part is exist already. So up to this you have to stop it off. So write the integral part 0. So now what you have to do is you have to make the process by adding the values all. So how you have to write? So first thing is you have to write from 0. Okay. So part is 0 point. So 0.2. So representation is 0.00110. Like that you have to write 00110. So 00110. Again 0 110, like that it will go on. Same process will repeat again and again. So 00110, again 0 110, 0 1100, like that it will goes on. Okay, so this is the output for converting fractional decimal to binary. Okay, ma. Next thing is decimal, that is binary to decimal conversion. What is the value? Binary to decimal. So for that, what are the steps? No, binary means it will be represented by what, ma? 2. Decimal means you have to convert it to 10. So convert, write the binary digit and list the power of 2 from the right to left positional notation. You have to write off. So starting from left, okay, starting from right, this part you have to write the positional notation value to the power of. Okay, like that you have to write the power of. Next step is for each positional notation, write from the digit. Now write the equivalent weight also. And then multiply each digit with the corresponding weight. Add all those values. So these are all the steps to be carried out for converting binary to decimal conversion. Now take down this example. Positional notation and weightages. For 0.2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 2 into 2, 4. 2 power 3 is 2 into 2 into 2, that is 8. 2 power 4 is 2 into 2, 8. 2 into 2, again 2 into 8 is 16. Next 2 power 5, 32. Like this, I return for 2 power 10, up to 2 power 10. So position value and it is weightage. Now take down this example. So this one you are going to convert 111,011 to the base 2 into your equivalent decimal number. So what we have to represent, ma? You have to write the positional notation along with the weightage of it. So position notation, what is the, have to write from left to right. Okay, so first one positional notation is, it is 2 power 0. Next for 1, 2 power 1. Next for 0, 2 power 2. So like that it will goes on. Okay, so then you have to multiply and add up with the position of that decimal. So first you write weightage. Weightage is what we are going to find hereafter only. First you write the given number. This column you write first. Okay, so given number is what? 1. So 1, again 1, 1, 0, 1, 1. So now write the positional notation. This value is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. Now compare with this table and write what is 2 power 0 value. 2 power 0 value is 1. So for that first one, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 6, 2 power 4 is 16 and 2 power 5 is 34. Then what the thing have to do? No, you have to add up all this value. Okay, that give the result. So I am going to add those all the values. So first value is what ma? 32 plus 16 plus 8 plus 4 plus 2 plus 1. Okay, so total is 59. So 59 to the base 10. So this is the output for the binary to decimal conversion. Clear? Okay, now moving to next binary to octal conversion. The same thing. The only representation is octal, no. So you have to write the power equivalent to the octal base. So octal base means what code we followed? It is 4, 2, 1. So this is 4 to 1. 4 plus 2 6, 6 plus 1 7. So my octal conversion is 0 to 7, no. So 0 to 7 value. So 4 to 1 code you have to write it off. Okay. So now see the steps. Group the given binary digit into 3 bits from the right to left part. You have to split and take the values into 3 bits. Okay. Then we can add proceeding 0 to make a group 3 bits if leftmost group has less than 3 bits. So if you are adding and coming to left, you are having only one number, means before to that you will may add 2 zeros, like that you can add up. Then convert the octal equivalent using 2's power positional notation method. That is your third step. Okay, now see this example. So octal number to binary equivalent we will write as previously 2 power notation we written, no, like that. So 0 to 7 I already told you. So 0 value is what? 000. 1 value is 001. 2 is 010. To compare with this 4 to 1 code. Okay, so here 0 means all 0. 1 means this column. This 1 only will get 1, rest to 0. 2 means 0 here, 1 here and 0 here. Okay, so that is the value of 2. Now coming to 3. 3 means 2 plus 1, 3. So what you have to write, ma? You have to write 1 for 3. Yes, for 3. This is 0, this is 1 and this is 1 for 3. Okay, so write. Next one we are going to write for 4. So 4 what you have to write, ma? 4 is 1, rest thing are 0. So 100 is the answer for 4. Yeah. Okay. Next for coming to 5. 5. 1, 4, 1, 0, 1. 1 not 1. Yes. Next coming to 6. 4 to 6. Okay. 4 and 2 we have to make it as 6. Okay. Next remove this one. 4 value is 1, 1, 0. So that is the answer for 6. 7 means all 3's are 1. Okay. All the values are 1. Then it is 7. Okay. Okay. So this is the equivalent. Next thing what you have to do is you have to split the values by 3 bits. So what you have to do from right to left, you have to split it off. I am going to split like this. So 0, 1, 1. So this is one set. Okay. Next 0, 1, 0. This is second set. Next 1, 1. Before to this you may add 0. Now calculate the value. What is it? 110. 110 means it is nothing but 6. So this value is 6. Next 010. That is 2. This is 2 and this is 6. So this is 2. Next one 011. 011 is 3. So this value will become 3. So the answer is 326. 326 to the base octal into octal. So to the base 8. 326 to the base 8. That is the answer for this. See, 326 to the base 8. Right. So what are the things we saw? The same implementation is here. Okay. So this is for finding octal equivalent of your binary. So now coming to next part, that is binary to hexadecimal. So what you have to do is you have to same as octal, only thing is you have to split it into how many 4 bit from right to left. Why it is 4 bits? It is indicated by using 8421 code. Okay, 8421. So you have to arose by taking the example of 8421, that is your octal code. So that is the first stage. Next one, you can add preceding 0 if the group is less amount. Then convert their equivalent using your 2's power positional weightage method. Okay, so that method you have to follow here also. Okay, now moving to this first thing. This is the value. You are going to convert it into hexadecimal. Now tell me how will you categorize 0, 110? That is your first group, right? Next one. 1011. So this one 1101 is your second group, right? Next 11. Previously you have to add 2 zeros. Okay, 0011. So this is the value. Yeah. Next we have to find the value of this positional notation. Okay. So first part, no, 0011, that is 3. For example, you may see this table. So this table you can represent, no, the first video itself I explain you. So what is the hexadecimal equivalent for this? Based upon 8421, you have to take it off. Okay, so that code dependent you have to take 8421, this one. So what is the example here we saw? Yes, these are 0011. So 0011 means what is the value of it? 0011. So compare this one. You just see 0011. Its value is what, ma? Its value is 3. So 0011 means that indicates 3. So what you have to do is you have to write 3 in this part. Okay. 0011 is 3. Then 1101. 111101, it is 13. 1101 is 13. So what is the value of 13? It is D. So we have to write it as D. Okay, ma? Okay. So the value is D, right? So this is D. Next is 0110. That is the next value. 0110. It is 6. So answer is what? 6. Okay. Next you take that one. So 6. So answer is 3d6 to the base 16. So that is the answer for this conversion. Clear, ma? It's very easy only once you understand. Next one, conversion of fractional binary to decimal equivalent. So what is your step 1 is, no? Convert integral part to binary, fractional binary to decimal equivalent of binary to decimal equivalent. First thing you have to do it of normal your integral part before to decimal using positional notational method. As we discussed already, no, same method you have to take it and calculate. Coming to fractional part, what are the things you have to do? No, write down the binary digit in fraction. Then for all the digit, write the power of 2 from left to right. Starting from 2 power minus 1, 2 power minus 2, like that it will goes on up to 2 power minus n. Okay, that is the step. Then multiply each digit with corresponding weightage, then add all the values same as we done before. Okay, so this is the positional notation and weightage, that is 2 power minus 1. 2 power minus 1 is nothing but half. 1 by 2 value is 0.5. Next 2 power minus 2, it is of 1 by 4, so 0.25. 2 power minus 3 is 1 by 8, so 0.125, 1 by 8. 2 power minus 4 is 1 by 16, 0.0625. Then 2 power 5 is 1 by 32, so 0.03125. Then 2 power minus 6 is 1 by 64. Value is 0.015625. Similarly, 2 power 7, 1 by 128, 0.0078125. Okay. Next thing is, to get the final answer, write the integral part after the conversion. Okay. Followed by decimal value. Okay. Now see this. 11.00, this one, for this number you are going to convert the decimal equivalent. Okay, so this is your binary number. I am going to calculate decimal equivalent for 11.011. So first thing is what? 11. So this one indicate 2 power 0 and this one indicate 2 power 1. Now moving to decimal part, this one indicate 2 power, it is to the rightmost. So 2 power minus 1, then 1 is, this one is 2 power minus 2 and next one is 2 power minus 3. Clear? Okay, now we have to multiply and add this value based upon your positional notation. So now here, what is the value? 3 plus, because integral part is 1 to the base 2. Referring your table 2.2, that is the table I show you now. What is the value of 1 means it will indicate the value of 3, right? It will indicate the value of 3. It means how they are writing now. As a 4 to 1 code, this 1 before you can add 0. Okay, so what is the value? 4 2 1. 2 1 means it is 3. 1 represent 3. Otherwise, if you write 8421 code also, first 2 digit will be 0 only. So 1 is nothing but value is 3. So that is the value here. Okay, 3. This 1 value, this integral part value, no, this 1 is to be represented as 3. Next for decimal plus point. So what is the value? 0. 0 into this position value is 2 power minus 1. This indicates. So what is the value? 2 power minus 1. Value is what? Next value is 2 power minus 2. Next value is 2 power minus 3. Here 1 into 0 into 2 power minus 1, 1 into 2 power minus 2 and 1 into 2 power minus 3. So everything will be add up of. Now based upon the table, you just refer it off. 2 power minus 1 value is what? 2 power minus 1 means 0.5. 2 power minus 2 is 0.25. 2 power minus 3 is 0.125. So these are all the values. Based upon the positional notation, you have to multiply and add all the values. That is 0.375. This whole value is 3. So 3.375 to the base 10. So this is the answer for this binary to decimal conversion. Here, next we will see about next conversion method, that is octal to binary conversion, octal to decimal conversion. Next we will see about octal to binary. So first is octal to decimal. For this you have to write down your octal digit by power of 8 from right to left based upon positional notation. Same thing we saw no for binary. Same thing we are going to do here also. For each positional notation, write the equivalent weight, then multiply each with its corresponding weight, then all those values. First thing what you have to do is 1. You have to represent this one given number. So 1, 2, 6, 5. Positional notation is 8 power 0, 8 power 1, 8 power 2 and 8 power 3. Then value corresponding is 8 power 0. Anything power 0 is 1. 8 power 1 is 1. 8 power 2 is 8 into 8, 64. 8 into 8, 64 into 8, 512. Okay. So you have to add all the values. So 512 plus. So this value is based upon into 1. So 64 into 2. Next 8 into 6. Then 1 into 5. Okay. Then add all those values. So the final value will be 693 to the base 10, because what equivalent you are going to do, that one you have to check it out. This is octal, by decimal, so to the base 10. Decimal means 10, octal means 8, binary means 2, hexadecimal means 16. Like that you have to make your representation. Yeah. Okay. Next we'll see about octal to binary conversion. Okay, for this what you have to do is, just you have to make your conversion to octal. First you write it off, because octal coding, that is 4 to 1 code, automatically you write all the values will come under machine language, that is zeros and ones. Then you combinedly write all the answer. So you have to split 6, then 2, then 1 and 3. Then write the corresponding 4 to 1 code of this. For 3, 0, 1, 1, right. 1, 0, 0, 1, correct. Then for 2, here will be 1, rest of 2 are 0. So 0, 1, 0, right. 6, 4 and 2 will be 1. So 1, 1, 0. Okay. Then write all the things down. 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, double 1 to the base 2. That's all. These are all very easy thing, ma. If you started writing and doing, means it will become very, very easy for you, and most interesting also, this conversion. Clear, student? Okay. Now we will see about hexadecimal conversion. Okay. So hexadecimal to decimal conversion. For that, what the steps? No, you have to write your hexadecimal conversion to the power of 16. We saw no for octal. Same thing for hexadecimal also. 16 from right to leftmost. Then you have to make your positional notation. Then multiply each digit. Finally, add all those things to get your result. Okay. So the same procedure. The only thing you vary is, here it is to be hexadecimal. So to the power of 16 we have to write. So 25f to the base 16, hexadecimal equivalent you have to write it off. So 2, given number is 2, 5, f is nothing but 16, 15. Okay, f value is 15. Next, this value is 16 power 0, 16 power 1 and 16 power 2. Right, 16 power 0, anything power 0 is 1. 16 power 1 is 16. 2 is 16 into 16, 256. Okay. So what you have to write is, you have to multiply this one. 2 into 256 plus 5 into 16 plus 15 into 1. Then add all the values altogether. So finally to the base is 10. That's all. Clear? Next thing is hexadecimal to binary. What you have to do? You have to place the value for hexadecimal, that is 8421 code. You have to split and write like that. So 8BC. For the 8 value is, how will you write 8421 code? 8, 4, 2, 1. Now the value is 8. What will be the answer? This column is 1, remaining all are 0. So 1000. For B, B is, what is the value of B? It should be 11. Okay, 10 is A. So 11 will be B. So 11 means 8 plus 2, 10 and 11. So 1011, right? Correct. Then coming for C. So it should be 12. 12 means what the value will become? 8 and 4 will give the value as 12. So answer will be 1100. So that is the answer for C. Yeah. Okay. Next thing is, all together you have to write it off. 1 triple 0, 1 0 double 1. Next 1 1 0 0. So altogether all to the base 2. Clear? Okay, ma. So up to this we will end our class. In next video we will learn about binary representation for your sign number. Okay, so binary representation for your sign number, we will see. Under that you will have 1's complement and 2's complement value. Then what is meant by sign magnitude. Okay, so now we will make a summary of this session. What are the things we gone through? Let us move to the summary part. You may work out this sample example. I will show you, I will give you as an assignment in your next session. So now take down the summary part of this session. So moving to the summary part, we saw about various conversions. One is your conversion of fractional decimal to binary, we saw. Next one, binary to decimal, binary to octal, binary to hexadecimal, then conversion of fractional binary to decimal equivalent. Next one, octal to decimal, octal to binary. Next, hexadecimal to decimal, hexadecimal to binary. So up to this, the conversion, whole conversion will get, because in last class itself we saw 3 conversions, no, decimal to binary, decimal to octal, decimal to hexadecimal. In today's class, we learn about binary to remaining conversion, octal to rest conversion, hexadecimal to remaining conversion and all. Clear, students? Okay, ma'am. Now we will see about your home assignment. Take down. First question. Question 1. Convert 62 to the base 10 into binary number. So what you have to do, ma? You have to convert your 62 divided by 2. Then have to make a reminder. Like that you have to make your conversion for calculating your binary number. So it carries 2 marks. Second question, convert 350 to the base 10 into binary, then convert that binary number to octal. So 2-step process you have to do. First thing is you have to convert this 350 number into binary. Then from the number, the binary will arise, no? From that number you have to convert that one to octal. So it carries 3 marks. Then coming to third question, write the procedure to convert fractional binary to decimal. Okay, so procedure, what are all the procedure followed to convert fractional binary to decimal? So first part is you have to convert your binary, then your decimal values. Okay, so after that mingle these two values by keeping decimal value in between, then write the binary part and decimal value conversion part. Okay, two output here, two in joining output you have to write it off. That procedure you have to write. Next, to convert 102.48 to the base 10 to binary. Okay, so this question, third question carries 5 marks, 2.5 and 2.5. 2 questions is there. Okay, students, hope you all understand the class well. Write the home assignment in each topic what I specified to you. When coming to the school, I will ask you definitely. So you have to write and keep along with you. Okay. Let us see one logic question today. So previously we saw about quotes, no? So today we will see about one logical question. These are all the questions to be asked in your interview point of view. Okay. So after completing your 12th standard, you have to make your mind to be facing all the challenges. So these are all the stepping up to you. So it will help you very well. Now listen the question. Breeze tends to cyclone. Drizzle is tend to what? So that is the question. So answers are earthquake, downpour, flood and storm. First you find the meaning for all the things. What is breeze? What is cyclone? What is the interlink between this breeze and cyclone? Check it out. Next find what is meant by drizzle. The same thing. Okay. So the drizzle, what is the same thing alternative to be replaced for the drizzle, comparing with this first part. So before this colon, double colon operator, no. So what is it? Breeze tends to cyclone. Similarly, drizzle tends to what? Okay, the options are available here. So just find this one. I will give you the answer in your next session. Okay, students. Thank you.